does it taste like a gusher?
Just because it goos doesn't mean it's gush. Waste.
Alrighty, hello. Welcome to, well, what week is this? Week 3. No? Actually, it's, good God, I'm losing track of time. It's week 4. Oh my, week 4 of my AAA character modeling workshop. Now, this week, and over the course of this week and next week, I think things are going to be a little bit loosey-goosey compared to previous weeks, as I mentioned during my last stream. For a few reasons. First and foremost, because on Thursday I'm actually going to be going to the Gnomon School in LA to attend a talk that actually a few of my coworkers are doing. It's called Be a Better Game Artist, and I'll post a link to that in the Twitch chat. And basically what it covers is, you know, how you can, well, be a better game artist, but a bunch of topics related to doing better art for games in a production environment. And that's going to be by Gavin Goulden, Jason Hickey, and I believe a couple of other folks. Gavin Goulden is my boss, the lead on my team, and Jason Hickey is the lead environment artist at Insomniac. They're going to be talking for an hour, hour and a half, something like that, and I'm going to be there. So I'm not going to be here on Thursday. So instead of doing a Thursday stream, I'm actually going to be doing a stream tomorrow, Wednesday, at this same time. And I'm going to be talking about some of the same topics that I discussed today, though I'll be getting a little more into some of them, or not so much into others. And those topics today are actually going to be a little bit varied. I'm not going to just stick to a single topic tonight. I'm going to be jumping around a little bit to sort of talk about different aspects of making hard surface accessories for character models. So in this case, I'm going to be making some shackles for this werewolf dude. Excuse me. And I'm going to be talking about the process that I'm going to be using for that, because you know, shackles themselves are fairly simple shapes, but those are going to lead me into the approach that I use for hard surface for characters, which actually applies to basically any hard surface object or, you know, piece of a character that you might see, whether it's a piece of armor or a helmet, you know, a pair of glasses, sometimes even shoes. I'm going to be talking mostly about hard surface today, but I'm going to be talking about the different aspects around hard surface, how those hard surface objects either fit around or connect to the more organic shapes of the base body. I'm also going to be talking about UVs for hard surface models, and different ways that you can approach hard surface UVs. And I'm going to also be talking about how you can use certain techniques, which are available in many different programs, to go from your modeling application, Modo in this case, but you could also do it in Max or Maya or any number of other programs. I'm going to be talking about the processes you can use to take your high poly models, your high poly hard surface models, and dump them into ZBrush so that you can sculpt on them, so that you can adjust them, do all kinds of stuff with them. I'm also going to just briefly touch on using the same UVs for both high and low poly models. That's something that's very useful, especially if you are going to have you know, multiple different characters having the same models applied to them, whether it's hands, like I mentioned last week, or things like helmets, or something that's supposed to deform to fit the shape of a body that might have, say, bone scaling or blend shapes or any number of other things like that. So today, tomorrow, both times next week, they're all going to have multiple topics that I'm going to cover. Tomorrow I'm going to be covering a little bit more of how you can create different types of accessories for characters. I'm going to be giving this guy some things like piercings. There are going to be some like buckles and belts and that type of thing, so that's what I'm going to be focusing on tomorrow. And then next week I'm going to spend a little bit of time, not too much time, but a little bit of time talking about clothing, and then I'm going to sort of finish everything off by showing how you can leverage the output that you get from something like Marvelous Designer to give you a really good basis for high poly models. And I'm also going to be talking about UVs for the clothing models that you create. So yeah, lots of jumping around, but all within the same sort of area. Sort of talking about stuff that's applied to models, whether it's high poly or low poly, and the ways that you can leverage UVs for any number of different topics and scenarios. So let's get started. I mentioned before that I'm going to be making some shackles for this guy. I'm going to be doing something fairly similar to what you can see here, with the general idea being that I want to give this character a little bit of backstory, some implied backstory, and the way that I'm going to do that is I'm going to have some shackles on him, and the shackles are actually going to have broken chains attached to them, and then next week I'm going to give him some clothes that are a bit torn up, along with probably something like a satchel. So to, you know, kind of imply that at some point or another he might have been imprisoned. You know, he might not have been able to get the shackles off, but he still has some equipment with him. You know, these are important things that are useful to keep in mind for video game characters, because they automatically just give your video game character some backstory just by looking at it. So that's sort of what I'm going to be doing. So let's get started making these shackles. And let's talk about the process that we use for making something like this. Now, I'm not a blacksmith. I am not a, you know, medieval or even like 1700s, you know, jailer or something. I've never actually seen shackles in real life, so it's important that I go and I look for reference of them. And you know, I've found through looking at various reference images that this general layout and shape for shackles seems to be fairly common. So that's what I'm going to. This is generally the image that I'm going to base these shackle models off of, and then I'm going to have some broken chains dangling off them, like I mentioned before. But something that's important to keep in mind when looking at reference images is trying to break down the different shapes and different aspects of the model that you can simplify and sort of break down to their component parts. So in this case, actually, let's open this in Photoshop and do something that we did a while ago, which is draw over some general shapes just to get a good idea of what we're going to be doing, what we're going to be modeling. And then from there, we're going to use that drawing that we use, or that we make, as a sort of map for ourselves. This kind of map is, it's very useful because what it does is it gives you a constant point of reference when you run into situations where you're not quite sure how to make something. So we're going to open this in Photoshop, and we're just going to start drawing over this. This is just going to be a reference image, and we're going to try and figure out some of the shapes that we need to use and some of the structures that we need to have. Now, in current generation AAA character modeling, you're going to run into a few things when you are making things like these shackles. One of the biggest things is making sure that they can articulate well. Now, shackles and handcuffs, they're meant to move. They're meant to move with your wrists, but they're also meant to restrain, and they also have some functionality that's based around movement. So let's first examine how we can make these shackles move, and then examine how we can make these shackles articulate to do the functional job that they're supposed to do. And this is something where if you're working with a rigging team who has to pass this off then to animation, both the rigging team and the animation team will be happy if they can actually set things up so that these move in a plausible and believable way. So let's separate these out into the base component parts that we have and go from there. Let's start drawing our map. And let's actually switch to the correct brush. That might be helpful. Here we go. Alright, so on both these shackles are pretty much identical. So we're just going to just trace over this one. So right now we can easily see that the shackle is two main parts, and these are the two main parts that you're going to be concerned with when you are handing this off to you know, a rigger or an animator or someone along those lines. You have let's turn off shape dynamics here. So for our purposes we have two main key components. We have this part right here, which is all one solid piece that connects to a hinge right here. And then we have the other piece over in this area. Now, this is something useful to keep in mind because it's going to inform us about how we actually structure the model before we even get to the modeling stage. So let's get into that then. Here we have some very simple shapes. We have some cylinders that are either very regular, in the case of this cap at the end, or tapered in the case of this piece. Now at the end we have a plate which comes along like this, goes around here, and there is a sharp crease along here. At the end we have a hole for the pin to go through, and this actually gives us a really good map to work with right off the bat. Knowing that we have cylinders here and here lets us block out those shapes very quickly and very easily in our 3D program, and then from there we get to the more complex shapes down here. However, we can break down those more complex shapes as well into further simplified shapes. So in this case we have this sort of thing going on. So you've got a hole right here with a pin inside, which is attached to the lock on the inside, and then right here, this is the hinge. This is where a pin goes down through there. So this part right here. Alright, so we already have some good structure here. So what this tells us is that this part up here needs to essentially be a cylinder with a thing extruding out from it. So here's our cylinder. Here is a thing extruding out from it in that direction. So breaking it down even farther, we can see that with this hole right here, this is actually just the cap for a cylinder, which has been split in half and attached to what is essentially a square. Now, since we know that this part is basically just a square, we can split it up in any number of different ways. We can attach it to these cylinders right here. So really, we now have a very simple map that we can refer back to later on if we're feeling confused about how we're progressing. Now this is something that I do all the time when I'm working with hard surface models. As a character artist, you're going to be asked to model things that are absolutely insane shapes on a regular basis. So the ability to break things down in this way becomes very useful very quickly. So now that we have this base for ourselves to work from, we can start to figure out how it's going to be constructed in 3D. So let's come back here and start doing that. and continuously look back at our map here. Alright, so we have two cylinders, the cap and the tapered piece. So let's start with that. And just like other objects that I've modeled, I'm going to keep things as simple as I absolutely can. So in this case, I can see that it'd be very easy to represent things with an 8-sided cylinder. By looking at this end right here, I can see that this part could be easily represented with 8 sides and then easily connect to this part. So what I'm going to do is make an 8-sided cylinder. And let's just hide the high poly for that right now. We're going to make an 8-sided cylinder. This is going to be the cap at the end up here. It's all going to connect to this piece down here, and it should all be very simple. Now there is a part right here which is going to give us some problems, but we can deal with that later on. We'll figure that out. That's not as critical right now because we just want to get the big main shapes. So let's get those big main shapes right now. So here's the cap for the end. Just move this up. We can do this. That looks like it's going in about far enough. Now this part is supposed to taper and go down like that. Alright. So now it's supposed to attach to this part right here. Oops. This part right here. So there's two different ways that we can approach this. And let's look at the two different ways. One, we can just sort of expand this outward and then thicken it like so to sort of match that shape. And then we can take these bits, oops, we can take these, flatten them out like this. And then let's turn on snapping. So we can snap to that, snap to that. So we can do things this way. Or if that isn't working out for whatever reason, we can undo all that. We'll keep this, but then we can just make sure the snapping's still on. Move this down, move this up. We can move this over here. Move this right there. And this here. Now we do need this hole right in this area. So there's a couple of different ways that we can approach that. However, the easiest way is just going to be to bevel this in right here, like so, and then come back in like that. Alright, so now what we can do, since we have the general shape like that, is we can start attaching this former cube to these bits over here. So the reason that I break this down in this way is that, one, it makes it easy to do modeling operations similarly to how I modeled all of this stuff. However, there are also advantages to breaking things down into the absolute most basic shapes, the cylinders and cubes and squares and such, because what that's going to let us do later on when we get to UVing is it's going to let us do some very, very simple and effective UVs for things like this bit, which is just a cylinder, which could be unwrapped as just a rectangle. This bit down here, which could be unwrapped in just a planar fashion. You know, this up here could be unwrapped so that you're just looking at a circle on the UVs. So that's the main reason that when I am doing high poly modeling, Even for characters, I'm still keeping in mind later on the same things that I keep in mind later on with this one. How am I going to subdivide it? Where am I going to add more detail? And how is that detail going to be unwrapped? So let's start connecting these. And actually, you know what? You know what we can do? We can just do this. We can weld all these pieces together like so. So by thinking ahead, thinking about how you're going to unwrap something, thinking about the processes that you're going to be using during your next step, it's going to make your life a lot easier than if you just go and you model some shapes and then you have to figure out how to unwrap them later on. By working this way, where I have a distinct map, I can break things down into their base components and think about how those base components would be unwrapped. And that'll make it so that I model in a way which keeps those constraints in mind and keeps in mind that, oh hey, this bit right here, which is kind of a weird irregular shape, it really is just a slightly deformed cylinder. So now I know that. Now speaking of that slightly deformed cylinder, let's pull this back a bit and make that cylinder. So I'm going to do the same thing. I'm going to try to make this the absolute simplest shape possible so that I have the fewest number of vertices to work with as possible. And then once I get to the stage where I want to turn this into a high poly, I'm going to start adding support loops, bevels, and creased edges in anticipation of bringing this into ZBrush and beating it up a little bit. So let's make another cylinder, but in this case, let's do this. We're going to make this about yay big. Let's look at it from this side. I'm going to have this snap to here, go over a little bit. Okay. So we want this to attach to the rest very easily. So since we know that we have 8 sides around here, we know that there's going to be a bit right in the middle here that can attach to this vertex. So as long as we get the general size relatively close, what we can do, let's just center this. We can snap these shapes all together, like so, and then if I do something like this, where I add a loop around the middle, I can actually bridge these things very easily. Let's add a loop in there, right there, and right there. Swoop. Oh, I'm used to my work keyboard shortcuts. Alright, let's bridge that. There we go. Alright, so we now have our perfect shape. And let's just snap this so that it aligns with that. And now that we have the general base shape for this, there is one more thing that we need to add, which is the cut along the middle right here. This part, which really should be pretty easy to do. What we can do is just deselect this stuff and that, and then bevel that. Now by by beveling that instead of just cutting a bit out or deleting a bit, one thing that we can do that's really handy is copy this part and use this as the basis for the other part of the hinge by cutting that and then just rotating it around. And that is going to attach to this component right here. So it's going to be this bit which translates into this entire loop. So once again, I'm thinking ahead about the process that I'm going to use for making the rest. And I can actually see now that this is not quite long enough. That's okay. We can keep adjusting as we move along. Now, let's hide everything else. Let's just weld all the vertices and then cut across here so we have some nice straight geometry. It's easy to work with without being a bunch of fairly annoying ingons or triangles or whatever that won't necessarily subdivide cleanly. Let's do this. Alright, let's turn off the grid so it's a little easier to see. Oops, what have I done? Oop, I screwed some up. Let's just do this. There we go. Alright. Sweet. Okay. So there is our big basic shape for that part of the shackle. Now we might want to do a few things like maybe make this bit rounded or something like that, but let's just look at how this is subdividing and the ways that we can use UVs on this stage of it to make life easier, or just to think ahead about how UVs are going to be working. So, as I mentioned before, these are all very simple shapes, and there are ways that we can unwrap this in very simple ways to sort of maximize the UV space that we have, to minimize distortion, and to make things as easy as possible to unwrap. So let's take a look at where we can add some UV seams and then try to figure out the best places for them. Figure out if we have them in the right locations or not. So one big part of the way that I like to do UV mapping is to make sure that I have big complete loops that I can select, like up here, that allow me to very easily, oops, let's just clear these UVs. We can just delete that. It's nice to have complete loops like this that I can just, double click to select, so that when I go to unwrap stuff, it just sort of, it just figures out what to do on its own. Now this is not perfect. We have a loop along here, so let's do this, and then unwrap that, and we don't need to worry about this right now. If we take a look at these, we can see that when it's unwrapped, it's very easy to get very clean, solid shapes that are, perfect circles or perfect rectangles. This is how I constantly think about what I'm modeling. How is this going to affect the way that it unwraps? If I did something like resize this and then go to re-unwrap it, that's going to change the way that it unwraps this island right here. So I might want to think about the best way to unwrap this if the end here is much smaller. For example, instead of maybe unwrapping this so that this part and this part are two separate pieces, because this angle right here, right along here, because this angle is fairly gentle, I might actually want to do it so that to avoid distortion, I'm just unwrapping it all as one piece. Whereas if this angle along here is closer to 90 degrees, this is where I'm going to be thinking about, oh, maybe these are better suited to separate pieces. So once again, thinking ahead, thinking about how the model is going to affect the UVs, how the UVs are going to be unwrapped at some point. These are important considerations to make at every stage of the process. And speaking of those complete loops, I don't have one right here. and that's annoying me. I would like to be just able to just double click on here and select the entire loop. So since this is a high poly, and actually since lots of parts of this are going to be, or actually the entire thing is going to be triangulated once it's in game, one thing that I can do is either rotate these to a more convenient spot like that. Oops. Like that. Or I can just make it so that those are just n-gons. Either option will work. And that will still let me unwrap that bit very easily by just double clicking like that. Now that's something you can do in Maya and I believe Max as well, just double clicking on a complete loop like that. Whereas if you have some sort of triangulation in here, it's always going to mess things up because the algorithm doesn't exactly know which way to continue the loop. Alright, so this section along here could easily be unwrapped as one solid piece. But let's continue modeling and talk about some of the strategies that we use for other bits. For example, how are we going to approach controlling how this smooths out once it's subdivided? You're going to want to maybe bring this into ZBrush, and ZBrush doesn't support n-gons, or at least current versions don't. So what can you do about that? Well, let's make the rest of this shackle, and then talk about ways that we can get this into ZBrush while maintaining the base forms that we like. These big nice shapes with big creases along here, and maintaining this cylindrical form. So let's just model out very quickly the rest of the shackle and go from there. So let's see here. We want this to be like that, more or less. It's not a perfect snap, so I'll just put it like that. Oh my, that is very imperfect, but that's okay. It's going to be beaten up in ZBrush anyway, so we'll not worry about it. So I'm going to extrude these out, like so. Now, when I extrude these out, you'll notice that, and this is something you'll see in basically any 3D program, is that they just maintain their orientation relative to one another. Now, that's not something that I necessarily like, because if I continue to extrude them out like this, they're eventually going to go through each other. So instead, what I'm going to do is I'm just going to extrude one edge out, and then thicken it so that I have a nice, big, chunky shape that's very easy to connect to the rest of the model. So I'm actually going to extrude this bit like so, and let's see here, we'll make a nice big loop out of it. Let's go back and look at our reference. So we have this loop going around this way. So it looks like it, ooh, hello Windows, it looks like it does just a nice, oh my goodness, looks like it does just a nice big curve, kind of along those lines, a little more regular than my goofy freehand noodly stuff, but yeah, so we're going to continue that shape so that it comes along, goes through here. So let's do that. Let's just extrude this out like this. And once again, I'm going to maintain as simple of shapes as possible for as long as possible. So you'll notice that along here, I've got 1, 2, 3, 4 edges that will very easily subdivide into 8 or 16 or 32, etc. Those are just easy to work with, and it's easy to do things like select every other polygon or every other edge. Let's go back here to this modeling tab so that things are a little larger. Alright. there. And then we're going to come down through here. Because, as we can see, this bit just curves down through the main cylinder. Okay, so now that we have this base shape, I want to thicken it. So I can do that. However, there is a problem with doing that immediately, and that is that the main shape of this bit of the shackle actually changes along its length. So this is another observation that you want to make before you actually get started with modeling. The main reason that you'll want to make that observation is because it could screw you up later on. So if you notice, along here, we have a cross-section that looks roughly rectangular. It's a little bit like a rounded rectangle, but then over here, you have, it looks like 8 or 10 sides, and then once it gets down to here, it's just a circle. So we have a long taper going along here, and that's something that we want to keep in mind. But the biggest part of that right now is making sure that this bit down here matches the shape around here. So this bit needs to be wider. So once again, we need to observe what we're looking at before we get started, and that's something I failed to do in this case. This is one case where I failed a little bit, so I'm going to need to go back and make some adjustments. If I had just done this the way that I initially thought that it was constructed, as opposed to the way it actually is, without looking at reference, then I'd be in deep doo-doo, because I'd have to go back and redo a bunch of work. Alright, so in that case, what we're going to do is we're actually going to take these bits, make them narrower, just for ease of use. We're going to extract these. There we go. Let's make this just a little bit wider. Okay, that's good. You know what? We do want this to curve a little bit, so here we go. Alright, so now I have the general base shapes for this thing. It's not perfect, but it's going to get the job done for now. Let's take a look at how it looks when it's thickened, and then we can start taking, looking into ways that we can attach it to this cylinder shape down here, so that it all sort of links together properly. Alright, so let's just select this entire thing. Just select the parts we want thicker, and then just do this. Here we go. Let's make sure that it's about the right thickness. Okay, it's okay. We're just going to eyeball this anyway. You can delete that. And then, let's bridge this. Close that up. Close that up. And here's where we start running into trouble. So, we do have 8 polygons going around here, but they're not 100% consistent in their width. So I'm going to use a deformation tool to make this just a circle. And what that's going to do for us is make it so that it matches the cross-section over in this area. We want it to be round as opposed to the shape over here. We want it to be round, so we'll just do that. And then from turning around, we'll just extrude this out. And since it has 8 sides, when we cap it off, one thing that's very handy is that we can do this to turn it back into quads. Alternately, we can leave this as just an ingon, and when you subdivide it, it'll make it so that you can turn it into quads this way, or in any other number of different methods. We'll just leave it alone for now. It's fine for now. But let's take a look at the rest of this. Okay. So we have our nice big basic shapes now. We have everything in place. We have the two components of the shackle. However, we need to make sure that they do have the sharp edges that you can see along here, here, there, and then along here, and places like that. So there are two different methods that you can use to achieve this. One is to add support loops, and you can do that by just simply essentially selecting all the loops that should be sharp and doing something along these lines, where you just bevel them or something. That works. However, over the past few years, a lot better, more elegant solutions have come to be that make things easier for us in the long run, and actually make it easier for us to subdivide things in such a way that we can bring them into ZBrush or some such. So in this case, instead of adding support loops, doing things like this or beveling the edges or something, I'm actually going to keep this polygon density, but then start adding edge weights. This is called creasing, or edge weights, Catmull-Clark subdivision weights, that type of thing. Basically what it does is it just tells the edge to stay where it is when it's subdivided, as opposed to moving like this. So let's do that now. Let's make this so that it's a little more highly subdivided. So it's not initially useful for bringing this into ZBrush at the moment. However, in a couple of minutes, what I'm going to do is I'm actually going to freeze all of the subdivision on this model, and then what that'll do for me is make it so that when it's subdivided, all of it is quads. You'll notice that even that huge ingon right here has turned into 8 quads. That's completely different than what you would expect if, or it's way more useful than you would expect an ingon like this to be. So, but that's what I'm going to do now, and then from there I can easily bring it into ZBrush and start sculpting it, beating it up a bit. So let's get into that right now. Let's start adding more edge weights to this, and talk about the ways that you can add edge weights and the limitations of edge weights or creases. So let's just add some, and then take a look at how they affect the model. And then, once we take a look at how they affect the model, we'll take a look at some best practices when using them so that we can get the best effects possible. Alright, so here we have a model that looks, I mean, it's a pretty serviceable high poly. There are still a couple of areas, like in here, that are pretty imperfect. You can see some odd deformation and such when it's subdivided. However, in general, this is looking really solid. But there are some problems, some pretty nagging problems in certain ways. First and foremost, we have this loop along here, which, as you can see, is making it so that with the edge weights, these polygons are being stretched upward along the length of this. Now, why is this? What's causing it, and how can we fix it? Now, this is something that you'll run into in basically any program that uses creasing or edge weights, and it's actually a pretty easy thing to fix in most situations. What is happening right here, and actually up here as well, you can see that there's just a big crease in the middle of the polygon as opposed to at the edge. What's happening right here is that this big long set of polygons right along here needs to subdivide, but when it's subdivided, you see that as we get more and more subdivided with it, it still stays so that it's big long polygons, and those big long polygons make it so that some of the tension from adding these creases goes not just in down into the crease down here, but actually gets spread out along the length of these polygons. So the best way to counteract this, the best way to make it so that you don't have any of this weird deformation, is to add more polygons, to make these polygons along here much more evenly distributed. The best way to do that is to add a series of cuts so that they become much closer to squares. So you'll notice when I go to subdivide this again that this area is going to be much cleaner, and the edge right along here is going to stay much closer to the surface that we see here as opposed to creeping up in this direction. There's less tension in this area, so it's not going to pull it as much. There, see? So this edge stayed down here, and it's just right at the middle area between this polygon and this polygon. But there are still other areas that are not quite perfect. And if we take a look from a side view, let's see here. There we go. So if we take a look from a side view, you can notice that there are still some problems. Namely, if we take a look at this edge right here, it's nice that it's going down towards the main surface of this object. However, we do have some more tension and some more weird stuff going on these polygons over here. So essentially we want to do the same thing. We want to make it so that these polygons over here are much closer to square, so there is less tension pulling them in other directions. So there are a couple of ways we can do this in this situation. What I am going to do is actually just cut straight across here. We have ingons anyway. We're just shortening those ingons. This ingon right here is just a little bit shorter, and we've just added some quads. Now that area has a lot less tension in it, it's a lot more evenly distributed, and it's going to have less weird deformation when you subdivide it. Now other areas that provide problems are things like these ingons right here. Because of the nature of this ingon, it's going to have a big just a big pole right in the middle of it. So if I subdivide this a few times, you'll notice that you have 8 edges just radiating out from the center just because of the subdivision algorithm. That's not great. So there are two ways that you can, two primary ways at least, that you can counteract this odd deformation along the edge here. One is to actually turn this into a spike and intentionally use that pole in there, because what that does is, once again, it redistributes the tension so that it goes more evenly across here. Or alternately, what you can do is you can bevel this in like so. Either option is viable. However, if you have polygon density that is not consistent, like you have right here and right over here, what you're going to end up with is much sharper edges, or slightly sharper depending upon how dense it is. You might end up with sharper edges along here than over here. So that's something to keep in mind. Depending upon where this is happening, it might be useful, it might not. For example, along the top here, I could use either option. I could turn it into a spike right like that, or I could bevel this in. Now in this case, I probably want to not have a sharp line along there. Probably want to have it so that it's actually round. And then this will just have, oops, this will have no weight on it. There we go. And then this one as well. There we go. Now it's nice and round. Okay, so there are other areas with problems. For example, this area right over here is not actually cylindrical in cross-section. You can see that it's a bit of a weird shape that's getting tension over here and straightening these polygons out. This is a simple fix. All you need to do is select along there and then set it so it doesn't have any weight on it. Alright, so we're in a pretty good spot with this. I'm going to fix up a couple of other weird areas, and then I'm going to talk about how you can actually bring this into ZBrush while maintaining some of the slightly weird topology that we have. We have a lot of ingons on here, but there are things that we can do to make it so that even with ingons in this version, we're still able to import it into ZBrush. So let me just fix some of these problem areas, and then we'll start talking about that. So we want to even this out a little bit, even this out a little bit. Let's do that. Let's turn off multi-slice. Okay. And this should not be hard-edged. Let's make sure it's not. Okay, cool. So we'll turn the... Ooh. Make sure that we got some good topology down here by slicing across there, across here. Now you notice that with this subdivision algorithm, you don't have to worry quite as much about ingons or triangles because they subdivide pretty cleanly. I do have some triangles in here, but you don't really notice just because of how cleanly it subdivides. Alright, now let's take these, make them into spikes. Alright, make that into a spike. I'm going to make this one as well. And then these two. Alright, so let's take a look at this. Let's make sure everything is in the right spot. There we go. Alright, now using creases like this does have limitations. We've seen a couple of instances of limitations, but one I do want to point out while we're on the topic is this right here. Now if you have a curved surface that it's curved along here, you want to maintain a pretty simple, smooth shape. However, when you run into situations like this where you have 5 or 6 polygons going across that edge and you're using subdivision weights or creases or whatever, it's not going to subdivide super cleanly because once again, you do have some tension in there. So one thing that you can do to counteract that is, once again, use ingons to your advantage. Make sure that that's the same weight. Alright. So by removing some of the polygons in there, we make it so that this is a much cleaner transition from the top to the bottom. Now it's not so noticeable in corners like this because the shape is actually concave, and it actually supports the shape that we have there. But for areas along here where it's supposed to just be straight, that's where you run into problems. So we'll just remove that. And that's a lot better. It's much cleaner. All right. One last thing before we bring this into ZBrush is to make sure that this part of the model has a hole to go through in this bit right here. There are a couple of different ways to approach this, but because we started off with an 8-sided cylinder, something very convenient for us is that we can actually sort of bevel this out and attach it to various existing edges in a way that takes advantage of the way that 8-sided cylinders subdivide. If we just bridge those and add some edge weights, add a loop along the center. All right. So since we have 8 sides, it's really easy to drill a hole through the 8 sides, or it could be 16 sides or 32 or any number of others. But yeah, oops. Let's see here. Let's remove that. And we can also make it so that this edge is easy to sort of bevel and add a wider edge to. All right, so I've got a question in chat. Are you preparing this just as a base mesh for sculpting in ZBrush, or will this also serve as the final low-poly mesh? The answer is yes. It's going to sort of serve as both. I've got some odd stuff going on here, so I'm going to remove a couple of edges. There we go. That's nice and smooth now. It's easier to see where the detail should be. So yeah, the answer is sort of yes to both. I am modeling this to bring into ZBrush, but I'm also modeling it with the final low poly in mind. And I can show you how I'm going to use the low poly, or use the high poly as a base for the low poly by simply, oops, let me just get this in the right position. There we go. Does bend a little bit in a weird way, but that's okay. I mean, this is not supposed to be perfect. It's just supposed to sort of match. There we go. And this is kind of loosey-goosey, but there. We have sort of a pressure fit sort of situation going on there. Regardless, one of the advantages to using subdivision weights like this is that we can use it for both the high poly, and if we subdivide it in the right way, we can also use it as a basis for the low poly. Now what I mean by that is that since I have all these hard edges, and I'm being conscious of where I'm putting hard edges and how I'm laying things out, I know that along a lot of these hard edges, like for example along here, I could very easily put a UV split along there. And if I freeze the subdivision on this, which I'm gonna just take this down a little bit. If I freeze the subdivision here, now this is pretty dense, but I can really quickly and easily go in and remove any extraneous edges like this, to make it so that this could easily be very quickly turned into a low poly model. So I can remove every other one, since I started with an 8-sided cylinder. Oh, maybe not that middle one. So if I go along like this and remove every other edge, it starts to very quickly start looking like a low poly model. This is one other reason why I use 8, 16, 32, 64 sides, because once it gets to the point where I want to change the high poly to a low poly, it's very easy to remove any sort of detail. So this model that I'm making right now, this one before subdividing is actually a little lower than I'll be using for the final low poly model. This has less detail than I want, so I'm actually going to be using, maybe subdivision 1. Let's try that. That's a little closer. I mean, there are still some pretty chunky shapes in here, but you know, around here I've got some nice detail. It'll be easy to unwrap. It won't be too dense. So I'm really doing both. Right now I'm making both the high poly and the low poly model just by making sure that I am keeping everything nice and clean. So speaking of freezing subdivision levels, that was what I was going to get to. Now, remember when I had this big ingon right here and I subdivided it? It made a bunch of four-sided polygons, made 8 four-sided polygons. Now that's very handy for us if we want to bring something into ZBrush, because what it means is that since we're not going to be worrying about n-gons anymore by, you know, after we've subdivided it, we can freeze the subdivision levels and then bring it into ZBrush and do things like reconstruct subdivisions. So let's actually do that now. We'll subdivide this a little bit more, just so we have nice, smooth shapes. We'll just copy this to a new file, just so that we don't screw anything up there. Geometry, freeze. It's going to take a second. Okay. So same number of polygons, just instead of being subdivisions, it's just actual polygons. Now I'm ready to actually take this into ZBrush. So let's just save this. It's going to take a second. Give me a moment to actually save this. Shackle base. Shackle high base. There we go. Save that. Let's switch over to ZBrush. And import it into here. Well, hopefully. Oh, there we go. Oh, you know what? Let's make sure that we're taking advantage of every single pixel on the screen by just making a new document. There we go. Switch to something less eye-searingly awful, and import that. Let's just get that model. Alright, so here is the high poly that we just subdivided, and you notice that the areas where we had ingons, like the top right up here, are not presenting us with problems anymore because we subdivided it and then froze the subdivisions. That means that we can import it into ZBrush, and then if we go to Geometry, Reconstruct Subdivision right here, we can actually get lower levels for it. Down to a certain point. It's not going to ever reconstruct down to the point where you have ingons, simply because ZBrush can't handle ingons or triangles very well, but now we have something that we can work with, and I can actually, you know, I can make large-scale deformations on this very easily, or any number of other, you know, modeling and sculpting operations. Let's just undo all this stuff. There we go. So there we go. So then, once you're done in ZBrush, you can actually export this as, you know, a lower subdivision level or the highest, and start baking your baking your textures. Now, before I do this type of thing, probably what I want to do is let's go back to this shackle. probably what I'll want to do is UV map this. So let's get into the UV maps for this. Let's talk about how we can leverage UVs for both the low poly and the high poly. We can use we can use the same UVs for the high poly and low poly, and then do things like very easily bake textures or create other types of textures by having similar UVs between the two. So let's do that now. So we already have some base UVs for a couple of parts, but let's just redo all of them. We don't need to save any of this stuff. And there are other bits on this, like the pin you can see in here, and you know there's bits of the locking mechanism, but we're not really going to worry about it right now. This is mostly for demonstration purposes, and I'm going to be doing some of that sort of Food Network type stuff where they go and finish off the model between between airing or whatever. So between today and tomorrow, I'm going to be doing a little bit more work on this shackle to get it closer to the concept, and from there we'll start talking about integrating it with the rest of the character. Beating it up in ZBrush a little bit to take advantage of some of the damage effects that we can get, other stuff like that. But for now, let's just start talking about UVs. So I already have those base UVs that I had before, but now one of the things that I have, now that I've rounded off the top for this and made some other adjustments, is a couple of complex shapes that I might not necessarily want to be unwrapped in this straight type of way, or I have some things that would benefit from that. So let's take a look at where it's most appropriate to add more UV seams. I have a question in chat. Will the Thursday talk be available to stream afterwards? So yes, the talk that I'm going to be attending, I'm not going to be speaking in it, but I will be there, which is why I'm not going to be doing the stream on Thursday. I'm going to be doing it tomorrow. They will be both live streaming it on the live stream website and on YouTube, and it will also be available, as far as I know, forever on YouTube after that. So yes, you will be able to watch that. That will be on the Gnomon YouTube page, which I can link in the chat. I failed to link to it before, so let me link to that article that talks about it real quick. Let's see here. Here we go. Here's an article on ArtStation about that talk, and that should have links to everything that you need. The live stream website for Gnomon is just livestream.com/Gnomon. That's GNOMON. And the YouTube channel is just a bunch of letters and numbers that I'm not going to read out, but if you just go and search for Gnomon on YouTube, you should be able to find it pretty quickly and easily. So let's take a look at the UVs for this guy and see how we can speed up our process, see how we can take advantage of the basic shapes that we have, and sort of lay things out in a way that will make it easier for us to bake, to do things like add noise in ZBrush. Let's just get into that. So I mentioned before that I like having complete loops like this, and I've retained that. I've retained that in the high poly, and there are lots of areas that have fairly continuous loops that I can just double click on and start getting good UV seams for. So here we go. Here's a good start to the UVs for our model. By just selecting these, what's going to happen is all the planar parts of this, all the parts that are nice and flat, are going to be unwrapped such that they have as little distortion as possible. This large cylindrical piece is going to be unwrapped as its own almost rectangle. You know, this bit along here, once again, is going to be a rectangle. This part is big and flat. You can unwrap that all as its own single piece. And because it connects very continuously to the part below it, you can unwrap all that as a single piece. This is stuff that I've been keeping in mind as I've been modeling this whole thing out. And it's something that, you know, keeping those next steps in mind, the UVs and every other part of this process in mind as you're doing one step, thinking ahead will save you time once you get to that step. So let's just hit unwrapped and see what it does. Oh, looks like I missed a couple of edges somewhere. Oh, here we go. Right along there. Oops. You can just select along there. Unwrap. Oops. What do we got? And what is this piece? Oops, looks like I missed an edge along there too. There we go. All right. So there we go. There are some basic UVs for what we have so far, and you know they will be easy to subdivide and simplify. They'll be easy to paint textures on because we're keeping in mind where all of these either hard edges are going to be in the low poly, or you know how we can split this up. By breaking things down into their component parts like I have here, we make sure that we know exactly how each part is going to be taken apart and put back together. Alright, now let's do the other chunk right here real quick. We've got, let's see here, got a bit along here. This part is probably going, ooh, well, that's doing something interesting. Let's just make that into a big old ingon. Redo that seam. You know what? This is an area where we could stand to add a little bit more topology to make it easier to unwrap. And actually, that's not really going to make much difference in the high poly, aside from slightly flattening out some of these shapes. But, because we're going to be beating this up in ZBrush later on anyway, we're not actually going to notice that these have slightly more topology. Now, if we really want to, we can do something like double the number of edges along here, so that instead of 8, we have 16. Either option works, and either option can result in a nice cylinder. It really depends on what you want to do. So just close this off again. There we go. It's nice and clean. We'll be able to cut it up nicely. And actually oops, what have I done? Let's make sure that's visible. By adding those extra loops, one thing that's nice is that I can actually add another one right here, and I won't have to deal with any ingons in that area, or at least not as many. Let's cut this up. Oops. There we go, that's better. Or perhaps not, it just doesn't want to. Well, it doesn't matter because I can just mirror it. Let's see here. We'll turn this into a nice spike. And then it'll be easy to mirror along here. clean this up. There we go. That's a little cleaner. Nice. Now it's completely symmetrical, and it has retained all the hard edges, while these bits up here are still round. Alright, sweet. Now, since this part right here is one big planar area, I can unwrap that either separately or as part of this. I'm going to include this because that angle right in there, this one along here, is not very extreme. So it'll be fine. It won't really present any deformation issues or texel density issues in the UVs if it's unwrapped as a single piece. Oops. Alright. Now, one area that we can add a split is right here. Now, why would we want to add a split right here? I mean, it really depends on the final effect that you're going for. Oh, and I've got still got some geometry issues here. Let's just fix that. There we go. So, one thing I can do is I can unwrap it so that, oh my goodness, this was not as symmetrical as I thought it was. How terrible. Oh, I'm ruining everything. Make sure that's the one there. Alright, there we go. So, I want to be able to unwrap things in a very planar way with big, very non-distorted UV islands. And this part of the mesh actually presents me with some problems in that regard, because what I have is a very smooth transition from a hard edge along here into a soft shape along over here. So one way that I can sort of get around that is by putting a UV split maybe along here, or alternately what I can do is I can have a UV split being in the place where nobody's actually going to see it most of the time. And that would be along the interior of here. Now, since the end of this is essentially the tip of a cylinder, I can actually unwrap it as its own singular piece, and then the rest of it will unfold so that it's almost like a flattened piece of paper. Oops. Or like a piece of origami that's been unwrapped. Alright. We're going to maintain these islands that we made before. And these are a lot of things that I like to keep in mind when I'm not just when I'm doing hard surface modeling, but also when I'm modeling characters in general. I've mentioned several times tonight keeping in mind the next steps, keeping in mind where you're going, and I find that it's very useful to keep that mindset for everything, because it will eventually speed things up for you. So let's just hide everything else and take a look at this. Alright. So, by putting a UV split right down along the center, this is going to be covered up by anything the shackle is actually around, whether it's a wrist or an ankle or any other part of the model. So contrary to what I might do if this was a completely hard-edged model, where I would have UV splits going along all the hard edges, instead I'm going to have the UV split going right along the center, and the part that's actually going to be exposed to the outside is going to be the part that doesn't have a UV split. And it looks like I have accidentally merged some vertices. That's part of what's going on there. I see. Silly me. There we go. So that's where they were merging. Right down in there. Okay. So we'll just cut this chunk off. It looks like when I was doing some stuff with symmetry, I accidentally merged some vertices. So I'm just going to cut this off real quick. No problem. So while I'm doing this, if you have any questions, feel free to put them in the chat, and I'll be happy to answer them if I can. If not, I will just say I don't know. I don't know the answer to that question. But if it's anything having to do with, say, modeling or texturing or UVs, any general game industry queries, that type of thing, I'll be more than happy to answer if I can. But regardless, here we have the island for this guy, the UV island. So let's just relax this guy. All right. Now, one way that you can think about UV islands is how would I split this model up if I wanted to maintain hard edges by, instead of doing smoothing groups, just cutting pieces of the model. And that's actually sort of the basis for how you do a lot of hard-edged UVs anyway. So that's the method that you can use for a lot of this stuff. For example, I might want to have these bits right here as, separate pieces if I was going to split things up to get hard edges. So that's right around the edges of this guy. This is where I would put my UV splits. Now, I don't necessarily need to have a UV split along here, since this will all unwrap nicely as a single island, but either way kind of works. One way will maintain some of the crispness of an edge, but since it's on the inside curve and it's going to be in the middle of an area that's largely covered, you don't really need to worry about that so much. Alright, so what's this a little bit? Oh, there we go. Alright, so here we have some really temporary UVs, but they're serviceable for now. Now what I'm going to do is just make sure that these are fairly tightly packed and bring the whole thing into ZBrush, pound it out a little bit, just with some quick strokes and stuff, just to make sure that make sure that I'm not making dirty jokes here. You know, just smash it up a bit with some of the brushes in there just to give it some dents and stuff, and then bring it back and bake it out very, very quickly. And one of the things that I'm going to do is I'm actually going to bake this very quickly in Marmoset, and I'm going to use the UVs for the high poly and keep them the same for the high poly and the low poly, and then I'm going to just be able to transfer the texture both from the high poly to the low poly and back and forth. It's a pretty neat little trick. I learned it from a guy named Ben Hale. He's a concept artist, illustrator, and 3D artist. He's kind of a Renaissance man, and he's brilliant. So if you like cool stuff, you should go check his stuff out. Now, regardless, let's let's just pack these UVs real quick. Not do that. Okay, there we go. That'll sort of kind of work for now. It's not going to be perfect, but it'll get the job done. So now, let's do the same thing that we did before. Let's go to a new file. Let's subdivide that. Geometry freeze. So as I mentioned before, this is going to be the basis for both my high poly and low poly. So let's save this. Doop-de-doop-de-doo. It's the wrong tab. There we go. Let's import it into ZBrush. Let me make sure that Marmoset is set up properly over here. While that's doing that, we'll just do some stuff like this, just to give it some dents and such, make things a little less even, a little more handmade looking. Now there is a detail on the back of the shackle over here, which I haven't gotten to tonight. That's going to be something where I just add it between streams just so that we can get through this quickly. But that's the part that'll be attaching to the chains. And tomorrow I'm going to be going over how to make chains, a couple of different methods that you can use, because there are many different types of chains and many different types of ways to make them. So I'll be going over a couple different ways to make them, and then we can sort of progress from there into putting things. Oh, just a second. Oh, sorry about that. Had a cat emergency. So once we talk about making chains, I'll talk about different ways that you can pose them, and then from there we will put them on our crazy werewolf guy. So let's make sure that Marmoset is ready to go. There we go. All right, so now we're going to bring this back into Marmoset now that we've just beaten it up a little bit, and let me just add a big old scratch right there. Maybe one along here. There we go. That's nice. Maybe a little deep. Bum, bum, bum. Huh. Okay. There we go. That's nice and beaten up a bunch. So let's export this. And you will notice that if I come down here to texture map, I can create a texture from UVs, and it has retained them in ZBrush. Now with this, with these UVs, I can do a lot of cool baking operations. So that's what I'm going to do now. So let's export this. Shackle high, sculpt, and let's just put that in here. So there's a question in chat. Hey, I'm a Max user myself. What drew you to Modo? Is it a specific feature set or just the general features of the Modo toolkit? Well, there are a few different things that drew me to Modo originally. And it looks like I imported the wrong model in here, so I should probably not do that. Should probably get the correct one. Let's see here. Okay, sculpt. There we go. I want the sculpted version, not the original. So I originally started off 3D modeling in Lightwave 3D, which, you know, at the time it was trying to compete with various other programs, but it was sort of, even then, falling behind a little bit. So when Modo started up, it was actually made by some of the people on the Lightwave team who left to found Luxology. And one of the things that I liked about it is that it retained a lot of the same tool functionality that Lightwave had while just expanding and improving on that functionality. So that was what initially drew me to Modo. It was something that was familiar, that I knew that I didn't have to worry about relearning a bunch of stuff. It just added small tweaks and adjustments. Now, the reason I've stuck with Modo is that I really like the way that the tools work. I'm not a huge fan of the modifier stack in Max, because as a character artist who does lots of, say, organic sculpting, or, you know, working with models of clothing or scan data, it's just not very useful to me. It's a lot more useful for high precision technical work that relies on, you know, hard surface or stuff that's going to be mechanical. So it's just not something that I find terribly useful in my day-to-day job. Whereas with Modo, I can just model and retopo stuff that's very organic without having to worry about the workflow too much and how it's being constrained or not constrained by the tools. The reason that I don't use Maya is mainly just that I haven't had much reason to use Maya. But also, from what I have found, most of the tools in Maya don't have the same sort of flexibility and initial approachable sort of behavior that a lot of the modeling tools in Modo do. So that's one of the reasons that I've stuck with Modo instead of switching over to Maya. I know that there are plugins for both those programs that make things a lot easier, but I just find that out of the box, Modo works the way that I would expect it to work and want it to work. So let's take a look at how we can use those high poly UVs to do something pretty cool. What we're going to do is first let's come back here to Modo, and let's make a low poly model for this guy. And we're going to use the same UVs. These UVs are by no means optimized or, you know, using the right amount of space. We're only using like 60% of the UV space, but we're not going to worry about that for now. We're also not going to worry about the fact that there are a couple of like weird overlaps and stuff. This is just for example, but it's to show a kind of a cool workflow that you can use to make sure that when you're using very high quality, very clean, high poly models, you can leverage that along with those high poly UVs onto your low poly models. So let's make a low poly model from this just by lowering the subdivision level and freezing it. Now this is not going to be perfect, as I demonstrated before, but it's going to be sort of good enough. We can remove some of this excess geometry just to make things easier to work with in the end. But really, you know, we don't really need to worry about the geometry for this too terribly much. We can get rid of some if we want, but really it's not going to make a huge difference. We'll just get rid of some of the excess loops and call it a day. Okay, so here's our low poly, you know, air quotes low poly. There's a lot of optimization that you could do. There are a lot of areas that are way too dense, but in general, I mean, it's workable. It's okay, but it still retains the same UVs that we had before. And the key to that is that if I have this model and this model, and they have the same UVs, I can bake textures from the high poly to the high poly, from it to it, without having the intermediate step of importing this low poly model into Marmoset, getting a cage going, blah, 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 blah. I can just bake the high poly. So let's do that. We're not going to make normals because the normals won't really show any difference. But the main thing we want to keep in mind right now for this is that the low poly should have a very, very short or even non-existent raycast distance. So that's going to be, if we click on here, we'll just put the offset to 0.001 so that it's barely even noticeable. What that's going to do is make it so that any weird interpenetrations are not going to interfere with the raycasting when we go to bake some textures. So let's bake an object-based normal map for this guy. Just bake that. So there you go. There is an object-based normal map that could be converted into a tangent-based normal map. Oops. Or let's bake some curvature. Now the curvature is based on actual polygonal or vertex curvature rather than something that's baked as like a difference between the high and low poly. So that's something that you can get even with just the high poly. We've got a bunch of curvature in here. We can bake some ambient occlusion, which is going to take a little bit longer. Let's just turn the raise for that down so it doesn't go forever. Let's bake some ambient occlusion. So once again, this is a technique that I learned from Benjamin Hale. He showed this to me after he had baked some textures for some clothing and found that as long as the low poly UVs were very similar to the high poly ones, it was very easy to bake normal maps or ambient occlusion or anything else by just having high poly UVs and baking that. Yeah, so here is our ambient occlusion. So now that we have, or well, if I'd actually saved it to a location, we could actually take a look at this. Let's take a look at the bigger preview. If we look at this, we can see that here are those same UVs that we have over here, and since all the UV positions are identical, we can just transfer these maps over without having to do any extra work. There's curvature, there's object space normals. I mean, we can do all of this stuff, and it's fantastic. So we're kind of winding up at the end of this session now. We're in the last roughly 15 minutes. So if you have any more questions, if you have any questions you want to put in the chat, I'm happy to answer them. While you guys are coming up with those, I'm just going to talk a little bit more about the next session tomorrow and then next week. Tomorrow I'm going to be getting into finishing up these shackles and posing them so that I can use them on this crazy werewolf dude. Oh, what's going on there? That's wrong. I'm going to be putting the shackles on his wrists, and maybe like on his ankle or something like that. I am going to be closing up his mouth at some point pretty soon, and over the next over the next 3 sessions after today, starting tomorrow and then into next week as well, I'm going to be talking about UV mapping for the body. I'm going to be talking about clothing. I'm going to be talking about making clothing and taking clothing from Marvelous Designer to ZBrush and then to low poly. I'm not going to get too deep into that, like I've mentioned before, because clothing on its own is a pretty big topic. There's a lot of literature out there that you can take a look at anyway. But in general, clothing follows the same topology rules for the rest of the body, as you would expect. Pants will be generally shaped like legs. Shirts will be generally shaped like torsos. And I'm going to also briefly cover things like hair cards. If you've been paying really close attention, you might have noticed that I actually smoothed out this area of his jawline from previous versions because I wanted to add some hair cards in here. I'm going to be adding hair cards over the course of the next couple of weeks. And I'm going to show the process that I use to do the basics of adding hair cards. It's a pretty simple process, but it is kind of time consuming, and the initial learning curve is fairly steep, which is why I'm going to touch on it and talk about the different methods that you can use to edit hair cards and that type of thing. So we got another question in chat. As a hard surface guy, I typically make use of layered UV maps and sets to get the most space. Is this that's something you can do with characters and organic modeling, or does it cause more issues than it's worth? That's a good question. Multiple UV sets do often come into play for characters, although one thing that you'll notice is that you don't often share UV space as much between different parts. So for example, if you have a large flat piece of metal on the deck of a ship and you want to put a rivet on that same piece of metal that's supposed to be made of the same piece of metal, you could probably get away with having that rivet and the rest of the metal share the same UVs and just have the rivet offset in some way so that they just share the same material. That's not something you run into with characters so much because so much of characters is fairly unique by design. However, you will run into situations where you'll want to do things like mirror UVs for, say, faces or hands or feet. If the face is completely symmetrical left to right, that's a place where you could just mirror the UVs. Reusing UVs between, say, hands, or using the same UVs and textures for eyes, maybe mirroring teeth, things like that. Those are cases where you'll have stuff in the same UV space. There are other instances where you'll have more than one UV set for the same piece of a character. So, for example, I might have multiple UV sets for this guy's torso, and the advantage to doing that would be that I could make it so that this guy has one set of completely unique UVs that are specialized to his specific body, But then the other UV set could match to a set of textures for things like muscle deformations or clothing deformations. And this is where things like wrinkle maps and blend shapes come into play. If this guy was wearing, say, a tuxedo, you'd probably want to be able to make it so that like the crook of his elbow in here, not only deforms correctly, but also has some wrinkles that fade in and out when he is bending his arm. So that is a case where having secondary UV sets comes into play. And those will be things that you'll want to talk to your, whoever's rigging this about, talk about it to them. You'll also want to be talking to and getting involved with whoever is doing the shaders and any sort of maybe character-based scripting, that type of thing, because activating things like blend shapes and secondary UVs for wrinkle maps, those are very different depending upon which engine you're using. But as far as sharing the same UV space for maybe, say, like a piece of his cheek and his bicep, that's not going to happen as much as you would expect in lots of hard surface modeling and prop modeling and that type of thing. All right, so let's just keep noodling away at this guy. We've got roughly 10 minutes left in this stream before I go into the private hangout with people who signed up for it. Unless there are any more questions, it's probably worth mentioning that I am planning on doing another workshop like this one. And the next one will actually be focused on creating textures. Specifically creating textures and materials for models and all the different components that go into that. So best practices for baking, different color levels and stuff that you might use for physically based rendering. General best practices for a lot of things, actually, whether it's albedo or specular or gloss. I will be talking a lot about those things. I am going to be taking a short break between the end of this workshop and the next one, so I'm probably going to end up skipping a month and then doing another workshop like this, but it's going to be focused mainly on texturing. So keep an eye out for more information as that comes up. I'll have more details over the next week or so, and I'll mention some more of the details in my next streams. One question I've got in the chat is this your workflow for pretty much all hard surface models? Do you ever model the high res first, then retopologize and UV the low res mesh afterwards, like a character/organic model? Yes, I do often I do often model the high poly and low poly separately. In that case, it's usually a situation where, say, the entire character has armor, or maybe maybe this guy is like some sort of cybernetic creature and he's got weird tubes and other stuff going in and out of different parts of his body, and having consistent UVs for that type of thing wouldn't necessarily make sense, because each little piece of the high poly would have its own UVs and that might not correspond to the low poly. So that's a case where I would use different UVs for the high and low poly, although for small accessories like these shackles, these are things where I will absolutely try my hardest to make sure that things have very consistent UVs, because I find that it's a very good way to work for smaller accessories or objects that are going to either not deform much, or if they do deform, they're going to deform in such a way that you don't really have to worry about the UVs getting messed up, that type of thing. One method that I like to use for certain types of high poly modeling is very similar to the method that I use for, say, this guy, where I sculpt out a high poly and then retopologize on top of it. The additional step in there would be that I will sculpt a basic shape in ZBrush with, say, Dynamesh or something like that, and then I'll retopologize that, and then from there I will finalize the high poly, do any sort of ZBrush work or anything on it, and then on top of that one I will retopologize for the final low poly. Although I will often integrate pieces of the high poly into the low poly so that things are nice and consistent, and positions for different pieces match, that type of thing. A lot of it depends on the type of project that I'm working on. For example, if I'm working on some sort of crazy cybernetic creature, like if this guy, like I mentioned before, had some sort of crazy tubes and stuff going into and out of his body, that's a case where I would certainly try to keep things consistent, and I would probably end up taking, say if he had a tube going from over here along the surface to down here, I would probably end up taking some of the topology from the high poly and integrating it into the low poly, even if the UVs are not going to be similar in the end. That's a process that I see a lot of people using, both at work and online or whatever, and it seems to work for a lot of people. Copying and pasting chunks of the high poly without necessarily retaining the same UVs. Doing that sort of copy and paste operation helps to make things very consistent and make it easier to bake, because you have things in essentially perfect location for baking. All right, so we're approaching the last 5 minutes here, and I just want to thank everybody for coming and watching. I also do want to make a small announcement. Starting probably next week, I'm going to be part of a project where game developers get together online and play games of D&D for your viewing pleasure. I'll be acting as the DM for at least a few episodes, and the first episode is scheduled to start filming on the 27th, which is a Sunday, and then it's going to air later in the week. That'll actually be the only pre-recorded episodes, just to get any of the technical issues out of the way. It's called Dungeons and Devs, and the focus of the entire thing is to essentially put focus on a lot of the people in the game industry who don't often get lots of public exposure. So usually people like directors, community managers, producers, designers, they have a lot of online and media presence, whereas people like programmers and artists and other folks who are in slightly more creative parts of the industry don't get as much exposure. So part of the whole goal is to, put those people in the public eye, make it so that people are aware that the people who make the models are actually people with personalities and lives who have things to contribute aside from just making models and stuff. So if you're interested in things like Critical Role or the stuff that the other types of streams and podcasts out there where people play D&D or other types of tabletop games, it might be something worth checking out for you. In the first episode, we're going to have a few different artists that I know. I'm going to be announcing those on Twitter over the next couple days, because we're still ironing out some of the details and I don't want to jump the gun. But I've got one of my coworkers along with a couple of concept artists and illustrators and an environment artist playing. So I'll be the DM for that, and they'll be the players. It's probably going to be roughly 3 to 4 hours long, and it's going to be airing sometime next week, although the exact date hasn't been pinned down yet, but I'll be announcing it on, social media and such. So keep an eye out for that. So we're in the last couple of minutes here, and I just want to thank everybody for coming. It's been a pleasure talking about this type of thing. I always like to explain some of my workflow and process, because I think that it's really useful being able to see process that people use, especially if it's something that they've tried to think a lot about or tried to develop methods for. So I hope this has been useful. And once again, not going to be here Thursday. I'm going to be here tomorrow, Wednesday, at the same time. And on Thursday, it'll be a talk. I'll be attending a talk at Nomon where some of my coworkers are speaking, and I'll just be there for moral support. So I'm not going to be streaming on that day. So if there's any more questions, I'll be happy to take them now. Otherwise, I'm going to be hopping into the private hangout and saying goodnight to you guys. Oh, excuse me. Alrighty, well, that's it for tonight. I'm going to be hopping into the private chat with people who signed up for it. If you have any more questions or anything like that, I'm always on, social media, Facebook, Twitter, that type of thing. So feel free to ask me there. It's always great to get questions in public anyway, because that gives people a chance gives more people a chance to get answers. So if you have any questions after this, feel free to ping me on Twitter or something, and I'd be happy to talk about stuff. Until then, have a good night. I'll see you guys tomorrow, and hopefully you'll tune in sometime next week once the first episode of Dungeons and Devs is finally up online. I'll make sure to put out more information about that as the week progresses, so keep an eye out. Until then, have a good night, and I'll see you guys later.